Hi guys, this is Mal. I'm taking you through IGCSE chemistry, and this is chapter 1, and it is about the particulate nature of matter. So in this video we're going to look at the states of matter, we're going to look at state changes, and we're going to look at gaseous particles. So let's get started then. So let's start with state changes. So we know that we have 3 states of matter, which are solids, liquids, and gases, and they are able to change state in a variety of ways. So first let's look at melting. So how does melting occur, and what does it really mean? So melting is when a solid changes into a liquid. So that is the change of state we are talking about. So it is from a solid to a liquid, and it only works in one direction. So melting requires an input of heat energy, which is then transformed into kinetic energy. And we know kinetic energy is the energy due to motion, so it allows the particles to move, and therefore the solid is going to start melting into a liquid. And it occurs at a specific temperature known as melting point, and this is unique to each pure solid. Okay, and if we move on, let's look at boiling. So boiling is when we talk about a liquid changing into a gas. So this is the state change, and boiling requires an input of heat, and this causes bubbles of gas to form below the surface of the liquid, and they then rise, and when they rise, these particles escape from the surface and within the liquid. So it is this process which we call boiling, and it occurs at a specific temperature which is known as boiling point, and it is unique to each pure liquid. Let's think of water. So we know water is a pure liquid, and the boiling point for water is 100 degrees Celsius. So this is just one example. Let's look at freezing now. Now the change of state is going to be from a liquid into a solid. So that's what happens when we freeze a liquid, it turns into a solid. So this is the exact opposite of melting. It's the reverse process, and it occurs at exactly the same temperature as melting. So from this, we can say that the melting point and the freezing point of pure substances are the same. So we spoke about water as an example for a pure substance. So if it freezes at 0 degrees Celsius, that means it's going to melt at around the same temperature as well. Now, freezing requires a significant decrease in temperature or a loss of thermal energy. So this occurs at a specific temperature, which is again unique for each pure substance. Okay, now what about evaporation? So evaporation involves the state change from a liquid into a gas, and it occurs only at the surface of the liquid, where the high energy particles are able to escape from the surface of the liquid. So be able to differentiate this from boiling, because we know boiling takes place throughout the liquid. However, evaporation only takes place at the surface of the liquid, and these high energy particles are able to escape from the liquid surface at low temperatures. So it occurs below the boiling point of the liquid. And the larger the surface area and the warmer the liquid surface, the more quickly a liquid can evaporate. Okay, and furthermore, no heat is required, and evaporation occurs over a large range of temperatures. So it only occurs at the surface of the liquid. Alright, what about condensation? So this is the state change from a gas into a liquid. So it's the reverse process of evaporation, and it occurs usually on cooling. So when a gas is cooled down, its particles lose energy. And the energy they lose is kinetic energy, meaning that they slow down. So they then bump into each other and they lack that energy which is required for them to bounce away again. So instead, they just group together, forming a liquid. A good example of this is perhaps a mirror in your bathroom or a glass, because after you shower, you'd notice that the mirror has a very light layer of liquid over it, and that would be because of condensation. And no energy is required for condensation to occur, and again, it takes place over a range of temperatures. Okay, so what about sublimation? So sometimes we can have a state change which doesn't work in the order of gas, liquid, solid. Sometimes it skips one altogether. We can see this is the case because sublimation involves a state change from a solid directly into a gas. So how does this occur? So this only happens with a few solids, for example, iodine or solid carbon dioxide. And the reverse reaction would also be called sublimation. However, in other textbooks, you may hear of it as deposition or even desublimation. And it occurs at a specific temperature which is going to be unique for a pure substance. Okay, let's look at this diagram over here, which shows us the interconversion of solids, liquids, and gases. So these are all ones we've spoken about before. So if we heat up a solid, we are going to get a liquid, and that is through melting. If we heat it up further, the liquid evaporates to form a gas. If we cool the gas down, condensation occurs and we have a liquid. And if we cool the liquid down further, it's going to freeze and form a solid. And as we spoke about, there are a few substances which can skip the whole process, and a solid can directly sublime into a gas and desublime into a solid. Okay, let's pay close attention to this exam tip. So often you will get a question on particle theory of matter, and it shows the interconversion of states with this reversible arrow. So for example, you will have gas, and then here you will have liquid, and then this would be the interconversion arrow. So it indicates that it can move in either one direction or the other. Now you need to read the question carefully and pick the direction of change in state that the question is referring to ensure that you get the answer correct. Okay, let's talk about gaseous particles now. So gaseous particles are in constant and random motion. So they have no pattern for their movement. And an increase in temperature is going to increase the kinetic energy of each of these gas particles. So when we have an increase in thermal energy, it is transformed into kinetic energy, which is the energy due to motion. Hence, the particles start moving faster. And if we decrease the temperature, we have the exact opposite effect. So they would begin to slow down. Okay, so the pressure that a gas is going to create in a closed container is produced by these gaseous particles exerting a pressure on the walls of the container as they collide with it. And as the temperature increases, these particles are now moving faster, meaning that they are colliding with each other and the walls of the container more frequently. And because they're colliding with the walls of the container more frequently, they therefore exert a greater pressure on it. So we can say an increase in temperature causes an increase in pressure. Okay, so temperature and pressure for gases are proportional. And let's look at this diagram. So these are moving particles of gas colliding with the container walls over here. So we can see that they move in a random pattern. They have no fixed direction of motion. They collide with each other and with the walls of the container, and they create an outwards pressure. Okay, so thank you. That has been our video today, and see you in the next ones.